Hello, and welcome to Lesson 5 of Learning Python. Today is going to be somewhat like Lesson 3 in that we are going to cover a lot of concepts, but they're going to be meaningful as we progress forward. Now, it is important to remember that as we go through these lessons, you're not learning every little nook and cranny of Python. There's actually a lot to Python that could easily take you a year to master. You're learning in terms of a goal, and our goal is to eventually being able to write a profitable trading bot. So there's a lot of things being skipped in the middle of different sections. Some of them will cover through the process of actually writing the bot when they get there, but some will simply be completely skipped over, like heaps or sorting. Things that we don't necessarily need to write the bot. This is a learn as you go and as you need approach. It's not what you would find in a university setting or in a formal education. It's what you would find on a job when you need to learn something to get a task done. Which often means the very first program you write for a concept is always the worst way to accomplish that concept. And that brings us to Lesson 4. Lesson 4 has a bit of a gotcha that I left in there deliberately. As you remember from yesterday's video, or the last video, I went through Lesson 4 quite extensively talking about how to actually validate the information from the user. And everything worked perfectly for the validation. Let's actually see how that does. So let's give a closing price of 23,000 and let's give a risk percentage of 1.5. Now, if you remember yesterday, I kept aborting the program here to go back into the code and work on that section that got the number for us. And as you can see, we have a bug. We have a problem. We know the number is a number, so what went wrong? What did we miss? The error type, unsupported operand for division, string and int. I gave a number with a decimal. So we already know it's not an integer. But remember what I said from Lesson 2. Whenever you work with the Python input command, no matter what you give it for information, it's always a string. So let's go look at the code. Okay, let's go back to our get user input. Everything looks fine. And I've had a few comments that have actually caught on to this little trick I left behind. What's wrong? Well, if you remember from Lesson 2, once you know it's a floating point number, you have to actually convert it into a floating point number. We didn't do that. Answer, when we return it back to the user or back to the main part of the program, is still a string. We need to actually convert that string into a floating point number by explicitly telling Python to use a conversion method. So let's go over that again. Input always gives you a string, even in the validation process as we have done. You still have to convert that string into a number. So now let's save this. Let's see if there are any other surprises left behind. Okay, closing price, 23,000. Risk percentage of 1.5. And it worked because now it has a number. Reward ratio. Let's do a 3-to-1 reward to risk ratio. Okay, so we now see that everything is working the way it should. And we have a meaningful program. I left that little gotcha in there for one simple reason. When you're looking at problems, bugs in a program, usually the simplest bug is going to be the most difficult to find. And something like this kind of a bug, where you know that what you gave it is a number, but forgot to actually convert it, can be one of the most difficult to find in a large amount of code. So if your program has grown to be several thousand lines long, one simple bug like that can have a lot of time to actually track it down. So now let's move on to lesson 5. For lesson 5, let's write a safe cracking program. This is a little game that's actually quite fun, but can be used to express a lot of different interesting concepts. Now these concepts are going to be very simplified compared to how the actual structures or methods we are going to discuss are used. So the first thing we need to think about in the computer world, if we're going to have a safe, we need a combination. That combination needs to be random. Well, we could just give the computer a number like we have been doing, but then we know what that number is. We need a way for the computer to give us a random number. So let's search. Remember from lesson 1 what Einstein said. Never memorize what you can look up. Okay, now we have the question, how do I get a random number? But is that really what we want? A number in Python can either be a number without a decimal point or a number with a decimal point, like 131.5679. Well, we could spend years trying to figure out that kind of a number. So let's refine our search a little more. We don't want just a number. We want a number without a decimal point. We want to make sure we can actually find this number. So here we are, our first example. Let's click on it. Let's read the code. 75% of the time you are reading somebody else's code. That is how you learn to program. You're actually only writing code 20% of the time. The other 5% is often either one, complaining to the machine or cussing it out, looking for bugs and problems, or two, trying to figure out what you broke and when you moved to the next stage of upgrading what you had. Either way, 5% of the time is done not writing code, and 75% is done reading somebody else's code. Only 20% of the time are you actually writing your own code. And even that may be questionable. Okay. Now here we have a few examples. And we have something strange. We have a function with a period. What this does is this introduces a library. Remember, from our own function, we can have multiple functions that do various things. And in this case, we're using a function somebody else wrote and put in a different file. For Python, anytime you put a function in a file, you can actually call that function and use it in your existing program. So let's actually go through and do just that. We're going to use this system library called random, and the function the developer gave it, randint. Now there are a myriad of ways of actually getting this information. As I have done previously, I'm going to pick the easiest, most direct route to understanding the purpose towards our goal. It's not the cleanest route, it's not the best route. It's the most readable route for learning. So let's go back to our VPS and actually begin to work with this. Okay, we are back at our VPS. And now let's actually begin to work on our safecracker program. Well, instead of calling this lessons, I'm going to call it safecracker. So let's start with the basic template we made and call it safecracker. Nice, simple, easy. Now let's go in and edit our safecracker program. Okay, we have the blank lines that we gave the program template that let us run this as a command. And it has universal formatting so we can share it with anybody in any country. Now, from the example we just saw, we need to use a library called random. And in that library, we need to use the function randint. So in Python, we actually have a special command to read in libraries. And a library is nothing more than a collection of functions somebody made for reusable purposes. And we will be making our own libraries throughout the course of this system. So let's start with, though, getting through the import command, the random library. Now this will tell Python that we want to use somebody else's code in our system. Now the importance of this is really basic, and it will get used extensively because there are a lot of libraries that we are going to need that deal with files and communicating with the exchange. If we were to write all of this information ourselves as part of learning, it would take us a year to get to the point of being able to write a trading bot. But by using a library where somebody else has already done a lot of this for us, we can take advantage of their knowledge in our program and simply focus on our objective, which is what we are going to do in this case. Rather than trying to figure out how a computer creates a random number, we're going to let somebody else who had half a dozen PhDs do that for us. And we are simply going to thank him and use his work. So let's start with something very basic. We're going to call this combination, and we're going to assign it rand int, and we're going to want it to go from 100 to 999. That is a 3-digit combination. But here's where we need to do things a little different, just like the example you just saw. We need to tell Python that the function we are going to call is actually in the random file or the random library. So now, the random library contains the randint function, and we want a number from 100 to 999. We don't want to deal with leading zeros, so that's why I'm starting at 100. Let's keep this simple to some degree. So, very simple, easy thing. Now, let's see what the computer actually gives us. Remember to always test what the computer gives you so you have an understanding of what it's really doing. Just like lesson 4 and that little gotcha, if you don't know exactly what the computer is giving you, you're not going to know why things break. And they will break over time. Simply because you've typed it wrong, or you've given a particular function that you didn't write the wrong information. Python or any programming language is a learn-as-you-go approach. And there are a lot of different little things that you can learn to really expand upon a given problem for a solution that can be simple to complex based upon what that problem is. So here we are. Let's save, okay, a blank line. Be sure you always end your programs with a blank line, because that can cause mistakes early on. So save it. Now let's go through and run Safecracker. 787, let's run it again. 349, 446. So we're getting what we want. We are getting a list of random numbers. And let's actually see this in action more thoroughly. I want to see 10 numbers. So for iterator in, and we're going to use a special function in Python called range. And we want 10 numbers. Now remember what I said in the last lesson. Numbers start with 0. So this is saying a range of 10 is really 0 to 9, which is fine, but we're going to get a count of 10. How it does it at this point is not that important. So we're going to iterate or count 10 numbers. And you don't have to start at 0. You can start, for example, at 2 and end at 10, which will give us a range of 8. But for now, 10 numbers. Always save your work. And now we have 10 different random numbers. So now we have the basis, or the first step within our Safecracker program. Now that we know the combination, a random computer-generated number, well, we're not going to tell the user what that is. The computer's going to hide that information. But we need to be able to ask the computer to make a guess. So for that, we need to use our input that we used in lesson 4. Now we can do two things here. We can just go back to lesson 4, copy it, and paste it into this program, which will work. Or we can make our own library. For the sake of this demonstration, let's make our own library. So we're going to save this, and we're going to copy lesson 4. Let's call this just library. Unoriginal, but library. Simple and easy. Now we don't need all of the code in library, because that's really lesson 4 completely. So now we need to edit out, oops, wrong file. We need to edit out all the stuff we don't need. What we need is numbers only, because that is called by get user input. But this is kind of misleading for general purpose. So we need to change this to get user number. Okay, so here we are, get user number. So this will be what we call from our library that gets a number. Now there's a little bit of a gotcha here, because this actually will accept a decimal point. We won't be using a decimal point, but for the purpose of this demonstration, let's just keep this simple. Part of what you can do is change that on your own as an experiment. What would it take to actually not allow a decimal point? It's not as hard as you might think. Okay, we don't need the rest of the lesson. We only need the 2 functions that we gave in that lesson. So now we have get number, get user number, and we have is numbers only. That's all we need. Save it. And now, like we did the system library, we're going to import our own library. We're actually going to take the code we wrote yesterday and use it to get the number we want. So, like random, we need to figure out, well, the user's guess is going to be from our library get user number, and now we need to give it the question. What is your guess? Enter a number from 100 to 999. So now, we know what the combination is. We want the user to guess what that number is. Okay, so far we're nice and simple here. We're using our function we wrote yesterday from the newly created library we just made. Now, if the guess is more than the combination, then tell the user their guess is too high. Okay, now here we can do else and then another if, and then if guess is less than combination. But as you can see, this can get crazy if you have a lot of tests you want to make, like in trading. You have 5 or 6 different indicators. You can see that this can begin to get messy as you have to indent each block. Luckily, Python gives us a shortcut. Instead of else if, we can actually use a combination of elif. So, which basically is else if combined, but it keeps our code readable. So now, okay, so now we have the situation of if the guess is higher than the combination and if the guess is lower than the combination. But we only are doing this one time. We need to repeat this as many times as it takes for the user to actually guess the number. So what do we need to do? Well, we need a way of looping or a way of waiting while the answer is wrong. So let's start with, we don't want to redo the combination. Once the combination is set, we want to leave it alone. So here is where we want to set everything up. False is a special word. Remember that from the last lesson. And now while not done. Now remember, in order for this to work, we want this block of code indented. So every line has to be indented. And now we can take advantage of this if the guess is not greater than the combination, meaning this condition fails, and it's not less than the combination, then it has to be the combination, or it has to be equal to. So at this point, it's not greater, it's not less than, it must be equal to the combination. But because we got the combination, now we need to tell the loop, the while statement, we're done. So now we have a complete working system. We've asked the user to guess the number. We're checking to see if it's higher than the combination, if it's lower than the combination, or if they actually got it right. And up here at the very beginning, we're using a system library to actually get the combination, a random number, specifically a random integer, from 100 to 999. So let's see how well this works. Or more specifically, let's see if it works as we intended it to. And it didn't. Okay, this did not work because we need to tell Python where to look for our library, and our library specifically needs to end with .py. A little bit of a gotcha here, but an easy one to fix. Now, if you remember right, we just named our library, but we really have to have that .py. Python needs to actually know it's a Python library. That's the easy part. The next part is a little bit trickier, but we will understand more of it as we proceed. That is, we need to tell Python to look in the current directory. In this case, the current directory I am using is home to learning Python. Now there's a way around that that's an easy way that we're going to use here. But as we progress, we're going to learn more advanced techniques that are actually better. But for now, in order to keep this simple, we're going to use the easy approach. But that requires another library. Remember what I said about the system library? Well, it just so happens Python has a very easy system library to work with. And now that we have the system library loaded, we can modify how Python looks for directories, folders, and libraries. We want to tell Python that normally looks in its system areas for a library, that we wanted to look in the current directory for our personal library. So sys.path, and we're going to give it a special parameter, and we're going to append the current directory. So the system library creates a special variable called path. That variable path is a list of everywhere Python is supposed to look to find its libraries. So just like we're using the special library random, well, here we're using the special library sys for system. Just like randint is provided by random, path is provided by sys. And now Python provides a special language or a special command that lets us add to an existing list. Path is a list. So the existing list, we want to add the current directory. In Linux, the shortcut for that is just a simple period. It's not the most elegant approach, and there are at least half a dozen better ways of doing it. But it's the easiest approach to learn to begin with. So now we are using two system libraries, or two built-in libraries in the Python. We're using the random library and the system library. And we're telling Python through the system library to use the current directory for our personal library. It sounds confusing, but the more you work with it, the more it actually makes sense and the easier it gets to follow the flow. But this is an important step when you start building large programs, because you will have special folders for your own personal libraries, and you're going to grow quite extensive over time depending upon how elaborate your project gets. So don't let it confuse you. Walk through it, talk through it, and you will make sense in the end. So now that we have this, and now that we've told Python to look in the current folder for our personal library, let's actually try this again. Okay, we want to save it. Now let's run it. Okay, it ran it, it loaded our library. Now, the computer has a combination. We need to guess it. Well, let's start with a little logic. We know the numbers between 100 and 999 because the computer told us that in the prompt. Let's start in the middle. 500. Okay, our number is too low. So let's try again another point between 500 and 999. So that's roughly 500 numbers, so let's go with 750. Now we're using a divide and conquer approach. Okay, so now we know the number is between 500 and 750. So now let's figure out where to go from there. The easiest point would be the middle. Well, 5 to 7 is 6, 625. Okay, so now we know 625 to 750. Well, 625 to 725 is 100, and half of 25 is 12. So let's do... So we know we're dealing with... So let's just go with 100, and let's see. So 725, which should actually be 12 more above that. So 24 and 12 is 36, so 737. All right, so it's between 625 and 737. So let's go with 680. Still too high. Let's try 650. So between 650 and 680, let's make that 665. Okay, too high. So 650 and 665, so 657. Too low. All right. 661. And we got the combination. So this is a fun little game that it goes through a lot of complicated steps. Not for actually the game, but for getting to the point of being able to demonstrate what we really need to know for beginning the point of building a trading program. We need to be able to reuse a lot of code quickly. So we need to store our functions in a library. We need to load that library quickly and easily, which means we need to tell the system where to look. So at the very minimum, these two lines are really the whole crux of this entire lesson. The random number is just a fun way of playing with the system. It's easy, it's simple once you understand it, and it really is intuitive. So Safecracker is a fun little toy that we're going to play with and do more with. Because the next step is, how do we get the computer to crack the number? Well, we already know through what we did. It's just a matter of figuring out the next step for the computer. And that will be the next lesson. But for now, have fun with the Safecracker game. Find out what happens if you change the numbers. What if you did from 1,000 to 900 to 9,999? How much longer would it take you to actually guess the number? Something else you can try to this is add a counter. How many times did you guess the wrong number? That's actually something that we're going to try right now. So first, let's give ourselves a number, a counter. We'll set it to 0. Every time we guess wrong, we need to bump the counter. Now there's two ways of doing that in Python. We already know simple mathematics. We can tell the counter the key is equal to the value. So the key of counter should be itself plus 1. This works perfect. But we can also go shorter. Python gives us a more intuitive approach. Plus equals 1. So add to counter 1. This shortcut, even though it looks strange at first, is very intuitive when you think about it. Whatever the counter is, add 1. And we're going to do the same thing if we guess wrong here. So, every time we guess wrong, we're going to add a number. So now, let's actually tell the user how many times it took them to find the number. So it took counter guesses. So, if you remember from our last lessons, you can combine information by using a comma. Now we're going to get more advanced as we go along, but for now, simplicity is the best way to learn. So let's see how well this works. Okay, it's got its magic number. Now it's time for us to guess it. Okay, too high. Okay. Too low. So now we know it's between 250 and 500. Okay, so we're kind of the same way as we was last time. 250 to 500 is 250. Divide that by 2. That's 125. Added to 250 is 375. Alright, so 250 to 375. Let's go. Well, that's, let's see, 125 divided by 2. 124, 62. So 250 plus 62 would be 312, somewhere in there. Okay, so between 312 and 375, I'm just going to start rounding here for ease. Let's make this, let's just guess 340. So 340 to 375, well, let's go with 360. We're still too low. Okay, 370. Okay, so 360 to 370. So 365. All right, 363. And it took us 8 times. So 8 guesses before we got the right number. So fun little way of doing it. Nice little toy. And as I said, it's a great way to learn. So I'm going to wrap this lesson up here. But don't let the unusuality of this get in the way. It's really not difficult. Libraries are really the best way to build on the Python because there are thousands of them available. And rather than trying to learn and write all of that code yourself, the library gives you the ability to use somebody else's work and even reuse your own work in the future. It's the best way and what makes Python so powerful. Because at this point, you're not just learning the language, because the language part is pretty much almost done. There are a few things for the Python language that I haven't gotten into yet. But once you start getting into the library, and libraries in general, it becomes more of learning about the library than about Python. That is, you are extending Python's ability beyond just Python itself, because the library is written in Python. So by doing this, like what we did here, through our own library, we extended it with our getUserNumber function. But this function calls another function inside the library that actually checks for all of the numbers. So these are just simple building blocks that can build a much bigger picture. Play with this, try different things, have fun with it, because a lot of programming is about having fun and enjoying being a programmer. Simple little toys like this in programming are always fascinating because they're so enjoyable, and they teach different levels of understanding, like the divide and conquer approach I used. We'll actually see that in the future more and more as you see that as part of an intelligence program or an intelligence process that will be teaching the computer for finding answers to problems in our trading. So like, share, subscribe, try it, write it, run it, test it. What else can you do with this program? And as always, from lesson 4, look at what you're actually doing. Because sometimes even the smallest little mistakes can be overlooked and missed. Don't fear the mistakes. Learn from them. And that's what will make you a better programmer over time, and what will help you accomplish your goal in the least amount of time. Until next time.